This video has been prepared to share valuable information regarding the planned development of the Pervari Dam and hydroelectric power project. As one of the largest single-site hydroelectric power projects initiated by the private sector, the Pervari Dam project represents a significant investment in the future of southeastern Turkey. And with increasing awareness of the effects of global climate change, development of renewable energy sources such as the Pervari Dam project are especially important to the region and the nation. Development of the Pervari Dam and Reservoir project will occur on Botan Creek in Sirte province, utilizing waters flowing from both Botan Creek and the Muku stream. Notable for its narrow and deep valleys and proven hydrology, the Botan Basin is one of the most suitable and underdeveloped river basins for hydroelectric power production in Turkey. With an overall length of approximately 240 kilometers, Botan Creek originates in the southeastern Taurus Mountains at an elevation of 3,500 meters. Initially flowing in a northerly direction, Botan Creek converges with various tributaries, eventually turning west at an elevation of 2,000 meters. After flowing for 100 kilometers, it reaches the Pervari area and further downstream, eventually joins with the Tigris River at an elevation of 450 meters. Among numerous tributaries to Botan Creek is Muku Stream. By diverting a portion of the flows from Muku Stream to the Pervari Reservoir through installation of a diversion system, a significant increase in the amount of power generated by the proposed project can be achieved. In addition to the Pervari Dam project, other hydroelectric projects are being developed in the Botan Creek Basin to take advantage of its unique physical and hydrological characteristics. Sirte province is among the more rural regions in Turkey and with approximately 300,000 residents, ranks 64th among Turkey's 81 provinces in terms of population. The area within Sirte province located closest to the project site is Pervari district. As this is the case throughout Sirte province, most of the district's 33,000 residents rely upon agriculture and livestock farming to earn their living. Located only 6 kilometers from the project site is the town of Pervari. Nestled high in the hills overlooking Botan Creek, Pervari is a small, quaint, and peaceful community of 3,500 residents. Here too, the economy is highly dependent upon the growing of grains, fruits, nuts, and vegetables, and the breeding of sheep, goats, and cattle. On the basis of extensive engineering, geotechnical, and hydrological studies, an ideal location for the Pervari Dam project has been identified just upstream of the town itself. Along with construction of the dam and reservoir, other major project components include a diversion tunnel and water intake structure, power tunnels, a powerhouse, upstream and downstream cofferdams, and the Muku stream diversion weir, inlet and outlet structures, and diversion conduit. Each would be developed within a construction zone straddling Botan Creek and Muku Stream. Among the first tasks undertaken will be construction of a road to the project site and a bridge to allow access to both sides of Botan Creek. Installation of such a road will allow easy access to the work sites by workers, equipment, and materials throughout the period of construction. The new road would also link the construction zone with a quarry to be developed within the eventual reservoir area. It is from this quarry that a large portion of the raw materials needed for dam construction will be acquired. A workforce of up to 1,000 workers will be needed to construct the Pervari Dam project, and so a self-sufficient construction camp will also be developed near the project site. The camp will include offices, workshops, storage and maintenance yards, and other support facilities. Worker housing along with dining, recreation, healthcare, and other services will also be provided as part of camp development and operation. It is in this time area that construction of the Muku Stream diversion system would also occur. There are inactive landslides located on each side of Botan Creek, just upstream of the dam site that requires attention early in the construction process. Each was carefully evaluated and a mitigation plan developed to ensure the safety of the dam and reservoir. To allow for dam construction, diversion of Botan Creek from its natural streambed is necessary. During this stage, an 8-meter diameter diversion tunnel and auxiliary intake and outlet structures are constructed. Botan Creek is then allowed to flow through the diversion tunnel, diverted by upstream and downstream diversion dams. The upstream coffer dam will be constructed of roller compacted concrete and extend to a height of 30 meters, while the downstream coffer dam will be rock fill and extend to a height of 4 meters. Construction of the diversion system is scheduled to occur over a 19-month period, after which construction of the dam spillway and bottom outlet structures can proceed. To provide the energy needed to power the turbines and generate electricity, upper and lower power tunnels and surge tank will be constructed. Extending 422 meters from the water intake structure, the upper power tunnel will connect to a surge tank located upstream of the powerhouse. The surge tank, 15 meters in diameter, will extend from just below the upper power tunnel to a few meters above the ground surface. Below the surge tank, a 119-meter long vertical shaft will connect the upper tunnel to a lower tunnel, which will extend 208 meters to the powerhouse. Construction of the power tunnels and surge shaft is expected to take 27 months, during which time construction of the dam itself will be well underway. Construction of the Pervari Dam will utilize roller compacted concrete, or RCC. Use of RCC is well proven and time tested and has 3 characteristics that make it ideally suited for dam construction: performance, economy, and speed of construction. Roller compacted concrete consists of the same ingredients as conventional concrete: cement, water, and aggregates. Batch plants will be established at the project site to produce the volumes of RCC needed on a daily basis. Almost 3 million cubic meters of RCC will be used in construction of Pervari Dam. Conventional concrete will also be needed, and a mobile batch plant will be used to provide conventional concrete for construction of the powerhouse and various other structures. But because RCC is much drier than conventional concrete, it can be placed easily using large volume earth-moving equipment instead of mixer trucks. After leaving the loading area, each dump truck travels to the leading edge of the RCC placement and backs up over earlier RCC placement. As the truck unloads, it moves forward, delivering the RCC and returning to the loading point to refill. Bulldozers then move in to spread the new RCC. A parade of smooth drum vibratory rollers then passes over the RCC, pressing the loose material into a dense, hard layer. Once a layer is placed, it can immediately support the equipment needed to place the next layer. Conventional concrete plays an important role in dam face construction, and careful attention is devoted to ensuring that the interface between the placement of RCC and conventional concrete is to the highest standards. Before placing fresh RCC, the previous lift surface is washed and cleaned with high-pressure water and air. A backhoe with a special attachment installs transverse contraction joints in fresh RCC at regular intervals to prevent uncontrolled cracking as the concrete cures. The compacted RCC receives a continuous mist of water to promote curing until subsequent layers are placed. Dam construction involves placing RCC in a sequence of carefully timed steps, requiring continuous coordination of batch plant operation, conveyor belts, pumps, trucks, rollers, and workers. In the case of Pervari Dam, RCC from the batch plants will be discharged to a conveyor system and delivered to a hopper at the truck loading area. When a truck pulls up to the loading point, the hopper's gates open and RCC is released, filling the bed of the truck. RCC is then transported by dump trucks, spread by bulldozers, and compacted by vibratory rollers. The dam is built up quickly as individual layers or lifts of roller compacted concrete are placed. leveled, and compacted in a continuous process. RCC has the strength and durability of conventional concrete, and in addition to its performance advantages, the ability to use conventional construction methods and equipment makes RCC an economically attractive technique. Sections are built lift by lift in successive horizontal layers, so the downstream slope resembles a concrete staircase. Construction of Pervari Dam is expected to take approximately 39 months. Development of the powerhouse will occur in a deep excavation located at the base of a steep hill approximately 800 meters downstream of the dam. The excavations will be designed and carried out to encompass the steel penstock area, which connects with the lower power tunnel at this location. Designed for a total installed net capacity of 400 megawatts, the powerhouse will contain 4 vertical axis Francis turbine generator sets. The 2 main turbine generator sets are each rated at 190 megawatts, and the 2 minimum flow turbine generators are each rated at 10 megawatts. Construction of the powerhouse and penstocks will occur over a 22-month period, followed by installation of the powerhouse electromechanical works during an additional 12-month period. The Pervari hydroelectric power plant will function as a peaking plant during 9 months of each year when water flows are low in Botan Creek. During periods of low flow, water would collect in the Pervari reservoir for most of the day, while 1 or 2 of the minimum release turbine generator sets would operate to provide the required ecological water releases to Botan Creek. During periods of high flow, all turbine generator sets would operate during the daily and peak load periods and operate as required during overnight periods. Among the last components of the project to be constructed will be the Muku stream diversion system. Designed to economically move a significant amount of water from Muku stream, the diversion system will greatly increase the amount of power generated by the project. The Muku's diversion system will consist of a diversion weir to impound and direct Muku stream flows through an inlet channel and inlet structure. A concrete conduit would then carry the diverted water to an outlet structure at Pervari Reservoir. Construction of the Muku stream diversion system is scheduled to occur over a 10-month period. Construction of the Pervari Dam and hydroelectric power project is to begin in 2010 and be completed in 2014. When this milestone is reached, water from Pervari Reservoir will flow from the dam intake through the upper and lower power tunnels into the powerhouse and through the turbines. The generators will then start producing 400 megawatts of environmentally friendly, sustainable energy. Turkey is one of the fastest growing electricity markets in the world, and clean, renewable electrical energy is in high demand to sustain continued economic development. You have the opportunity to meet this demand by participating in this exciting and financially attractive venture.